Factor out the greatest common factor. For this problem, what I want to do is I want to get the number that divides both of these terms, the biggest number that divides both of these terms. And when I look at 4 and I look at 6, I can see that the greatest common factor that I can take away from both of them is 2. And now I do the factoring process, and here's what you do. You divide each term by whatever it is that you factored. So here, 4x divided by 2 is going to give me 2x. And then negative 6 divided by 2 is going to give me a negative 3. And that would be the factorization using the GCF. If you're finding it difficult to find the greatest common factor, here's one suggestion. Get the biggest value out of your terms. So here that would be 6. And then count up to that number. So use every natural number up to that number. So for example, here I have 1, 2, 3, 4, 5, and 6. And now just check all of these values and see if they divide both of them. For example, here 1 divides 4 and 1 divides 6 evenly, so that's a common factor. Next, you can see that 2 divides 4 evenly, and then 2 divides 6 evenly. Here 3 divides 6, but 3 does not divide 4. So here we're going to cancel this one out because remember that they have to share, they have to have a common factor. Now next, 4 divides 4, but it doesn't divide 6. So here we cannot use 4. 5 does not divide 6 or 4, so we're going to cancel that one out. And next, 6 divides 6 evenly, but it doesn't divide 4 evenly, so we can't use this. So our options are 1 and 2, but we want the greatest common factor, which is why I used 2. Now let's try a problem with 3 terms. So here, if I want to get the greatest common factor, I got to look at the constants, 6, or I should say coefficients, 6, 18, and 12. They all share a greatest common factor of 6, so I'm going to go ahead and factor out a 6. And now I need to divide by whatever it is that I factored here. So 6x to the 4th divided by 6 is just going to be x to the 4th. And then we're going to subtract 18x to the 3rd divided by 6. We're going to get 3x to the 3rd. And finally, here we have 12x to the 2nd power divided by 6. So we're going to get a 2x to the 2nd power. Now, I want to point out that my terms, they still have another value in common. Notice that they all share an x, at least an x, right? Because now I have to look at the powers, and I'm going to grab the smallest power. Here, that's going to be x to the 2nd power. This tells me that I can factor out this x to the 2nd power as well. So now I'm going to bring x to the 2nd power along with the 6 outside of the parentheses. So I have 6x to the 2nd power. And now I'm going to divide my exponents here. And I want to take it back here. Whenever you divide exponents, so for example here, I need to compute x to the 4th divided by x to the 2nd power. So let me do this on the side. This is the quotient rule of exponents. Whenever you have the same base but different exponents and you're dividing them, you just subtract the exponents. So here, this would result in x to the 2nd power since 4 minus 2 is 2. So x to the 4th divided by x squared, I'm going to be left with an x to the 2nd power minus 3. And then x to the 3rd divided by x squared, again, we're just going to subtract the exponents. 3 minus 2 is 1. So we have just an x, or x to the 1st power, but I like to just write it as x. And finally, here we have x squared divided by x squared. That's just going to be 1, so we're left with 2. And that is my factorization.